Okay, let's talk about what happens if you have products and sums. So here's a differential equation. Y double prime minus 6y prime plus 9y equals, let's do this, e to the t times t cubed cosine t plus 4t cubed sine t. Okay, so first thing on the right is it needs to be factored a little more. We can take out a t cubed. So we have e to the t cubed, and then this is cosine t plus 4 sine t. Okay, so what are our rules for the method of undetermined coefficients? Okay, so we're going to solve first of all, the general solution to the homogeneous one. We can do that easily. We won't do that. And then we're going to guess a solution to the non-homogeneous one, any solution. Just have to find one that works. Okay, when things are multiplied, it's easy. You just multiply all your guesses. So our guess is going to be, for e to the t, it would be some constant times e to the t, right? And then let's call this a1. We're going to replace them in a minute. T cubed, you need a polynomial. Let's call this a2, and it's a degree 3 polynomial in general. Okay, so b2 t squared plus c2 t plus d2. You can use any letters you want here. I'm going to be replacing all these letters later, so I'm just putting subscripts now so I don't have subscripts later. Okay, and then this can actually be combined. Any linear combination of cosine and sine, as long as the inside angles are the same, we can say it's some linear combination of cosine and sine. So a3 cosine t plus b3 sine t. Okay, and then this is annoying to solve. So actually, when you multiply them out, what kind of terms are you going to get? You're going to get e to the t and cosine t with every power of t from 3 down to 0, the constant, and then the same thing with sine, right? So you're going to get 8 different terms, and would recommend multiplying them out to get the right number of variables, because this is only 7 variables. We want 8. So this is e to the t cosine t times t cubed. I'll put the t cubed in front, actually. So we'll call that a, and then we'll get b, and then the next one will be t squared, e to the t cosine t, plus c t e to the t cosine t, plus d t e to the t cosine t. And then you need to do all the same thing with sine. So plus, next variable, e t cubed e to the t sine t, plus f t squared e to the t sine t, plus g t e to the t sine t, plus h e to the t sine t. All right, so this is not going to be fun to solve, so we're not going to do it. But what we could do is we could take the derivative and the double derivative, lots and lots of product rule. By the way, product rule of 3 terms, so f, g, h prime, works the same way. You take derivative of one of them at a time. So f prime g h, f g prime h, plus f g h prime. That's how product rule for 3 factors works. So you would need that. We're not going to do it. We won't hopefully ever make you do it. Take the derivative and the double derivative, which would take forever. Plug those in. You can collect into 8 different terms. So there'll be terms like this, but there'll be linear combinations of a, b, c, d, e, f, g, h. Equate them over here. So only 2 of the coefficients will be non-zero. You get one coefficient of 1 and one coefficient of 4, and then everything else is 0. You've got a system of 8 equations and 8 variables, which you could theoretically solve. Probably would want to use a computer. And then you plug them back in. You get one particular solution to the non-homogeneous equation, add to the general homogeneous solution, which is easy. And then you have the general solution to the non-homogeneous equation. It would be very ugly. I'm sure there would be ugly fractions here. But you could do it. So you can do any products as ugly as you want. It just might take some work. Okay, sums. This is called the principle of superposition. Okay, so now what if you had this? You had y double prime minus 6y prime plus 9y equals, and a bunch of things added, e to the t plus cosine of 4t plus 5 sine of 4t plus t squared e to the t plus 3t. How do we guess that? Okay, let's combine the e to the t's. We want to combine these into as few terms as possible. That'll make it easier. So we've got e to the t times 1 plus t squared. This is going to be its own thing. So we'll put, you don't have to put parentheses, but this will remind us that we only need one guess here. And then plus 3t. And then what's actually going to happen, so you'll find the general solution to the homogeneous equation again. It'll be the same one we've already had. Let's actually write it down. Let's C1, this is just from memory, e to the 3t plus C2t e to the 3t. You solve the characteristic equation, you get a repeated root, so you get this t term. Okay, then what happens to the non-homogeneous part? Well, if I had some solution y1 is a solution to this differential equation. Y double prime minus 6y prime plus 9y equals just this first part, e to the t 1 plus t squared. And then y2 is a solution to this next part. So y double prime minus 6y prime plus 9y equals cosine 4t plus 5 sine 4t. And then y3 is a solution to y double prime minus 6y prime plus 9y equals this part, 3t. Then y1 plus y2 plus y3 is going to be a solution to the original equation. For the same reasons as we were doing before, we could add together the general homogeneous because that gave a 0 on the right, and the solution to the non-homogeneous part gave this part. Well, same thing here. We can actually split it up. The y1 will contribute this term to the right, the y2 will contribute the cosines and sines, and the y3 will contribute the 3t. So then what we can do, maybe we'll actually do this one. So we'll guess for y1 equals, let's look at what it was. We had an e to the t and a quadratic. Oh, maybe we won't do this one. I haven't decided yet. Okay, so we're going to have, let's say, a1 e to the t times the quadratic, which is going to be a general quadratic, a2 t squared plus b2 t plus c2. And what happens when you expand it out? You actually only get 3 coefficients. So y1 equals a t squared e to the t plus b t e to the t plus c e to the t. Maybe I will do this and you can race me. Or pause it if you don't want to try to do it fast. Okay, so what happens here? Well, let's see. We get y 1 prime is going to be okay, 2a t e to the t plus a t squared e to the t, derivative of e to the t is e to the t, plus b e to the t plus b t e to the t plus c e to the t. Let's collect some like terms here. We get a t squared e to the t plus, that's gone, the t's, t e to the t's, so 2a plus b t e to the t plus, and then b e to the t plus c e to the t. Okay, and then y1 double prime, we're going to take derivative of this, which is 2a t e to the t plus a t squared e to the t plus derivative of this, 2a plus b e to the t plus 2a plus b t e to the t plus derivatives of these guys don't change, plus b plus c, I'll leave that there, e to the t. Okay, let's combine those terms. We have this t squared term that's not going away, and then we have all the t terms. So 2a, and then another 2a plus b, 4a plus b, t, e to the t. Hopefully I haven't made a mistake yet. If you're watching this and you catch one, send me an email, please. And then add these together. This is 2a plus 2b plus c, e to the t. Okay, and that has to solve this differential equation, this one up here. So let's see, y1 double prime minus 6y1 prime plus 9y1 has to equal this other thing. Let's figure out what that is. So this is a lot of writing. A squared e to the t plus 4a plus b t e to the t plus 2a plus 2b plus c e to the t, right? Minus 6 times this, 6a t squared e to the t, plus, this is 12a plus 6b t e to the t, plus 6b e to the t, plus 6c e to the t. That's wrong. These are minuses. These are all minuses. That was a minus 6. And then plus 9 times y1. Plus 9a t squared e to the t plus 9b t e to the t plus 9c e to the t, right? Okay. Now let's collect all the terms. So we've got t squared here, t squared here. Okay, good. So 1 minus 6 plus 9 is a total of 4a t squared e to the t. And then we've got 4a plus b minus 12a minus 6b once we expand, and then plus 9b. So that's a total of negative 8a. This is a 1b minus 6b plus 9b, so plus 4b t e to the t. Okay, and then this other thing. So 2a plus 2b plus c minus 6b minus 6c plus 9c. So 2a minus 4b, and then 1 minus 6 plus 9 plus 4c e to the t. Hopefully I've done that all correctly so far. And that is supposed to equal e to the t times 1 plus t squared. So let's actually expand that out. So that's 1 t squared e to the t plus 1 times e to the t. Okay, so we compare coefficients. There's 3 coefficients to compare. So 4a has to equal 1. Minus 8a plus 4b has to equal 0. I'm going to put the 0 over here so I don't have a negative sign out in front that I can drop. And then this one, 2a minus 4b plus 4c has to equal 1. Okay, equations 1, 2, and 3. Let's solve this. Equation 1, a is 1/4. Let's plug that into equation 2. We get 0 equals minus 8 times 1/4 is minus 2 plus 4b. So 4b equals 2. b is 1/2. And then on equation 3, 2 times 1/4 is 1/2. Minus 4 times 1/2 is minus 2 plus 4c equals 1. So this is a minus 3/2. Add 3/2 to both sides. 4c is 5/2. So c is 5/8. So there we go. Our particular solution, we went back up to this line. We're going to put a, b, and c back into there. So y1 was 1/4 t squared e to the t plus 1/2 t e to the t plus 5/8 e to the t. Okay. And that worked because none of those terms corresponded to any of the terms here. Okay, that's good. We got y1. Got to find y2 and y3. So these can get really tedious. All right, so y2 is going to be a solution to this differential equation. So our guess for y2 is going to be a linear combination of, and then as long as these angles are the same, it's fine. We just got to keep them in there. So y2, we're going to guess a cosine of 4t plus b sine of 4t. Okay. Let's take a derivative. Y2 prime is a 4a minus 4a sine of 4t plus 4b cosine of 4t. And then y2 double prime is minus 16a cosine of 4t minus 16b sine of 4t. Okay, so then we plug it into this y double prime minus 6y prime plus 9y. y2 double prime minus 6y2 prime plus 9y2 is minus 16a cosine 4t minus 16b sine of 4t. We subtract 6 of those, plus 24a sine of 4t minus 24b cosine of 4t, plus 9 of those, plus 9a cosine of 4t plus 9b sine of 4t. And that has to equal cosine of 4t plus 5 sine of 4t. That's the rest of the differential equation. Okay, let's just combine like terms a little bit. So cosine, we get a minus 16a minus 24b plus 9a. So a total of minus 7a minus 24b cosine of 4t. And then we get minus 16b plus 24a plus 9b. So that's a minus plus 24a minus 7b sine of 4t equals cosine of 4t plus 5 sine of 4t. Okay, so this should be two equations, two variables, a little bit nicer than last time. We get a 1 in front of the cosine, so 1 equals minus 7a minus 24b. And then we've got a 5 in front of the sine. 5 is 24a minus 7b. Equation 1, equation 2. If I multiply equation 1 by 24 and equation 2 by 7, I can eliminate. So I'm going to do that. 1 times 24. I get 24 equals whatever that is, 7 times 24. That's going to be irrelevant. It's going to go away. 24 squared is 576. I memorized that when I was young. I think it's fun to memorize perfect squares. If you want to, it can help you a little bit, save you a little time. Equation 2 times 7. This is 24 times 7a minus 7 times 7 is 49b. Okay, that's equation 3 and 4. I add them together. This 7 times 24 is going to cancel out with this 24 times 7, right? Okay, so I get 59 on the left. The a's cancel out. I get a big number minus, let's see, 625b. Okay, so yeah, these can be pretty ugly fractions. B is minus 59 over 625. And then I put that into, what's going to be nicer? Probably equation 2. Okay, 5 equals 24a minus 7 times 59. 7 times 60 is 420, so this must be 413 over 625. So 24a, this is 3,125. I'm just going to write this down, over 625. Can do this all with mental math. Okay, so over 625, I'm literally going to subtract from the right one. 31 minus 4 is 27. Okay, and then divided by 24, ooh, that might actually go in evenly. All right, that's annoying. Let's see, 27, 12, I'm going to divide by 3 first, is 904, and then 904 divided by, can I divide this by 8? I think I can. This is 1, 1, 3. Cool. Okay, so A is 113 over 625. Okay, what does that mean? That means y2 is, I just got to put A in front of cosine and B in front of sine, like up here. So I get 113 over 625 cosine of 4t, remember the 4, plus, minus, this was a minus 59 over 625 sine of 4t. Okay, y3 is going to be the easiest because that differential equation is easy. Okay, so y3, we're going to guess general linear thing, so at plus b. We're lucky nothing had terms in here, otherwise we would have had to multiply by a t and everything would have been uglier. Okay, so y3 prime is going to be a. That's great. Y3 double prime is going to be 0. So nice. Okay, I've been doing all this ugly math. Y3 double prime minus 6. Y3 prime, this is the original differential equation now, plus 9y equals. Double prime is 0 minus 6a plus 9at plus b, and that has to equal 3t. Ah, such lovely arithmetic. 9at minus 6a plus b equals 3t. So I have two equations, two variables. 9a is 3, which means actually a is 1/3. And then 0 is minus 6a plus b. I can plug it in right here. Minus 2 plus b. Okay, so b must be positive 2. Okay, so y3, you can still see it on my page, is 1/3 t plus 2. Excellent. Okay, so what do I have? I have my general solution to the homogeneous version. I had y1, which I solved to get here. I had y2 was up here, and then I have y3, and I need to add all of them together to be a solution. So the general one was c1 e to the 3t plus c2 t e to the 3t. I'm adding y1 plus 1/4 t squared e to the t plus 1/2 t e to the t plus 5/8 t plus y2, 113 over 625 cosine of 4t minus 59 over 625 sine of 4t plus y3 plus 1/3 t plus 2. There's the general solution to the non-homogeneous differential equation, this ugly thing. And we can do all that. We can add as many terms as we want. It'll obviously get longer, but I wanted to show us plowing through that.